everyone. So we're going to start soon. Anyone could help us with Jabber? So, Eric, I, we have note takers, but we still need someone to follow Jabber, right? Or yeah, normally, yeah, not many people are anyway. But thanks for that. So, hi everyone. Uh, it's time now. So, welcome to the Interia working group. My name is Juan Carlos Zúñiga. My co-chair, Wasim, will be connecting remote. And we have Carlos Bernardos helping us here as a delegate. So let me move to the next slide. Doing a quick test. Okay, so far so good. Um, this is the Not Well, as any other IETF meeting, so please make sure that the various topics are presented in this slide, the code of conduct, patents, and be aware that by participating in this meeting, you agree to follow the IETF process and policies. If you're aware of any contribution being covered by a patent or patent application, you may disclose the fact to the list or contact the chairs. You acknowledge that this meeting is going to be recorded, so written audio and video photographing will be made public, and the personal information that you provide to this meeting will be handled in accordance with the privacy statement. Very specially, please make sure that as a participant, you agree to respectfully treat other participants. And we are very strict about any harassment or any misconduct issues. So please act respectfully. And if you have any questions, you have all the links there to the different BCPs. So um, we are going to ask you to help us if you want to uh, ask a question, do join the queue online, even if you are local here or remote, so that we can handle the order of the people and we will give you the voice. For those that have not seen it, please keep your mask on all the time and approach the mic only when you are called and your turn to the queue is arriving. For everyone else, please make sure that the audio and video are off unless you are presenting or asking the question. You have the resources here for the meeting, the Meetico tips, and if you have technical issues, you can contact the different teams at the IETF. So we have Minute Taker, where your presence has been logged through Data Tracker, what we call the blue sheets. And we are getting also help, thanks to the people helping us with the notes. So if you want to contribute to the notes, please do so. This is the agenda that we have for this meeting. We have 8 items. So first is our welcome, this presentation right here, giving you the status and update. But right now we don't have any working group documents, so it's a light one. Then we're going to have Seth talking about IPv4 policing at the IETF, Fred with IP parcels, Luigi for internet address gaps. Then we have the IP regional internet blocking considerations by Lenny, semantic IP addressing for satellite, higher layer address aggregation by Tony, and service routing in multi-access edge computing. So all these presentations are individual presentations. So far, we don't have any working group document. So they will be treated as individual contributions, all of them. We may do a little adjustment on the agenda down the road, depending on who's present, because there are some people that need to be in 2 rooms at the same time. But we will try to stick to this order. Are there any questions? Okay, hearing none. Let's move to Seth. Um, Seth, are you connected? Oh, yeah, I see you now.
Hi, do you hear me?
Yes, I can hear you. So I'm going to give you the control of the slides.
Okay.
I think you should be able to move back and forth now. Yes,
Sure enough. Okay. Shall I go ahead with this?
please do.
Okay, thank you. Hello, everyone. This is a new draft from our collaboration on IPv4 unicast extensions. So as people will recall, in November we presented the first 2 of a set of 4 drafts on our goal of conserving IPv4 address space. And we wanted to continue presenting the remaining 2 drafts, but there were a number of concerns that were raised in the November meeting. And as I'll discuss in a few moments, in our view, the heart of most of the concerns that people had with our drafts was about the appropriateness of working on IPv4 and maintaining IPv4 in the IETF. And so we wanted to go to the heart of the matter and see if consensus could be found about that deeper, more fundamental question. So we have a new draft that attempts to address this. We posted it. There's already been some discussion. The people who've commented so far were not very pleased or positive toward this, but I'm going to go through it and hope to help people understand it and hope people can help us understand their concerns. So our draft talks about the IETF's historic role as the steward of IPv4. It talks about challenges that have been raised in the IPv6 era to the IETF's role in continuing to maintain and develop IPv4. Notes that neglecting IPv4 is not our transition strategy and is not a strategy for causing the adoption of IPv6. Describes the likelihood and experiences indicating that IPv4 requires and will require ongoing maintenance. And notes that the IETF is in a unique position as the historic steward of IPv4, as the home of the most expertise, as the most conspicuous point of coordination for IPv4 and compatibility. And that IETF has unique structure and unique values that are historically well suited to consensus-based maintenance of IPv4 and related technologies. So as I said, this was inspired by our presentation of these proposals. I'm going to not talk very much about these proposals, but just clarify a couple of points as they relate to this, but mostly going to talk about the IPv4 question. So I did want to clarify something that a lot of people seemed not especially cognizant of, or that hadn't come up very much in the discussions, which is that the lowest address fix proposed in one of our 4 drafts is a fix that can be made locally with internet-wide benefits. So the lowest address is already interoperable across the internet with distant networks. If it's fixed to be supported within any individual local segment, it raises no allocation policy questions. It's already backwards compatible for distant networks, and operators of local area networks can make use of it whenever they know that the devices on their networks support it. And so, to the extent that people have concerns about allocation policy or about the difficulties in achieving internet-wide coordination, that draft doesn't raise those concerns. It does, of course, raise the concern of whether the IETF can properly continue to fix things in IPv4, whether it's worth it, whether it's appropriate, and so on. And so, again, that's some of the motivation here. So there's been some disagreement about how large or how exclusive this concern was, but we perceived that a very, very substantial amount of the objection or the concern about our proposals in November was based on the fact that they're IPv4 specific fixes. People said a lot of things that were quite disparaging toward IPv4, toward continued engineering work on IPv4, toward the role of such work in the IETF. And the strongest concerns that we noticed, and the most frequently stated that we noticed, appeared to be versions of, should the IETF still work on fixing IPv4? Why should the IETF still work on fixing IPv4? Or the sort of, this will only benefit IPv4 users who are using an obsolete protocol and should just switch to IPv6. Now, the IETF's role in maintaining IPv4 has been questioned before. One of the main outputs from the Sunset 4 working group in 2006 proposed that IPv4 should be declared historic and that IETF should, for the most part, cease to work on it.
Sorry,
when that draft,
what people online are saying that if you could move a little bit away from your mic because it's getting saturated. Thank you.
Maybe like this. Hopefully this is all right.
Yes, thanks.
Thanks for the feedback. Sorry about that. Yeah, so a main output of the Sunset 4 working group in 2016 made this proposal, and this went up for review as an IETF-wide consensus, and the community had quite substantial concerns about it, and it didn't reach a consensus. And so our hope is to see if the opposite consensus can be found. That is, people had objections to the idea that IETF should not do this work. We're wondering if people could perhaps agree that the IETF, in fact, should do this work and should continue to have this role. So IPv4, of course, is still the most used network layer protocol in the world. The IETF is the recognized and historic authority on all coordination and interoperability questions for that protocol. Those questions continue to arise. Our draft identified 10 RFCs over the past decade or so that impact IPv4 implementation, some of which are also applicable to IPv6, but that, in our view, made changes to the protocol or fixed things that needed to be fixed in the protocol. And we think that coordination and interoperability questions will continue to arise. So the first reply on the mailing list when we proposed our draft, which a considerable number of people replied indicating their support for and agreement with, said that our draft was unnecessary because it was a matter of common sense, that the IETF will fix things that need fixing even if they're specific to IPv4, but that it will only make serious fixes. So I found that to be a bit ill-defined, a bit non-specific, although it was certainly something that a number of people indicated their agreement to. We've found a lot of opposition to IPv4 work, but no clear policy that we can or can't do it. So I would ask, somewhat rhetorically, but also somewhat concretely and somewhat practically, can we clarify what common sense and what serious mean? And I would note that the other proposal that we talked about last time, the Unicast 240/4, is already the existing behavior of billions of devices. And it's plausible that it's actually the behavior of the majority of internet nodes. But it's something where there is far from universal compatibility, but it's quite a widespread behavior. And it seems striking to say that this isn't serious when it's a behavior, for example, that's already implemented in perhaps the majority of nodes and billions of devices across the internet. And I guess more concretely, it doesn't seem especially apparent to me, especially well defined in consensus, what this common sense or notion of seriousness mean or refer to. So I would hope that we could get and reach some kind of clear statement of IETF's relationship to these maintenance and coordination questions, which we think have arisen, are arising, and will continue to arise. And we query whether an alternate consensus may be found, given the lack of consensus for the declaring IPv4 historic position that was noted when that proposal was made. And looks like that's about it. And yeah, we'll take questions or comments. And thank you for your attention.
Thanks, Ed. Some people still say that they get too much noise from your mic. We hear you super well, but a little loud. So yeah, I think it. Thank you very much.
I'll move it further back. Sorry about that.
No problem. Thanks. So first online is Eric.
Thank you, Seth, for the presentation. Speaking with my AD Ed here, just to avoid any confusion by people listening to the YouTube video, this is an individual contribution till now and does not represent any IETF consensus. Now, I still wonder whether the IETF can commit to something forever. Right? We need to get an end date. And finally, I would love to get a clarification question out of you. You say IPv4 fix. Do you mean fixing the protocol or fixing the addressing or what? Thank you in advance.
Thanks. Yeah, so I don't know about the end date question. I think that's a great question. I think that kind of conspicuously to me, as someone who's been interested in IPv6 and the IPv6 transition for a long time, I don't think that there was really ever a transition strategy that had such a thing as an end date. People famously have said, well, there is no flag day, right? This transition appears to be, in practice, an indefinite thing. I don't mean to suggest that IETF should commit itself to a position that the IPv6 transition is permanent or never complete. But I do think that what we observe is that the IPv6 transition does appear from the present moment, from the present perspective, to be something that's very much incomplete and that very much has no projected end date, and that very much is anticipated to last for the immediately foreseeable future. And so I think it's worthwhile to acknowledge that. I would be happy to see proposals that try to formulate that or try to address that. I'm trying to recall your other question about where the fixes lie. For our particular proposal, we're proposing fixes that in the immediate term ought to be performed by implementers and ought to be present in IPv6 implementations, in IPv4 implementations, right? So we've been proposing and testing and looking at behavior typically of devices, typically of operating systems, typically of operating system kernels that implement IPv4. And they have commonly, in compliance with historic, not historic status, but older existing and still current RFCs, have treated certain addresses as inherently invalid under, one might say, under the protocol itself, that these addresses must not be used. And so when these addresses are encountered, certain implementations will actively discard packets. So I would regard that as a protocol fix. I understand that for everything except for the lowest address, there are certainly policy questions that are lingering about, for example, allocation policy. We've heard from several organizations that are using or wish to use reserved address space as RFC 1918 style private address space. And our proposals have been agnostic and silent on that kind of question. Clearly, that is a possible use that could be formalized, that could continue unofficially in practice, that could be the subject of an official designation. So all of the addressing policy questions and all of the other policy questions, our drafts have attempted to leave for another day and really focus on implementation behavior and say, you may have something in your kernel that inspects a packet, that inspects an address, that says, according to current RFCs, I am expected to drop this packet because this address is invalid according to the protocol. And that's what we want to see changed in the present moment in order to preserve maximum options for the future.
Thank you very much for this very detailed question. I think we share a point that V6 deployment should have been done for a long time. It's not the case, even if it's growing. Point taken. Now, as an individual contributor, I would be very reluctant to use the remaining IPv4 addresses that could be reserved for anything we can do just to gain 1 year or 2 years. But anyway, no need to reply on this.
I mean, I would like to reply on that because I appreciate the concern. And I gave a presentation about this at NANOG, and I had occasion to forward a question about exhaustion to someone who actively works in the secondary market for IPv4 addresses, and asked if we were able to use some kind of auction or market-based allocation mechanism rather than the RIR's non-market-based historic allocation mechanism in allocating a pool of addresses like this for global unicast. How long would they last? And his off-the-cuff speculation was 8 years. So I just wanted to put that out there in terms of people's concerns, because I understand that the demand has been quite voracious and that the exhaustion has happened quite rapidly. Anyway, I see there are 2 other questions and limited time, so I'd love to get the other questions.
Hi, Seth. It's Tom Hill from BT. I think it's sort of kidding ourselves a little bit to equivocate between fixes that are affecting, millions of people across the world, or fixes that benefit a few people. We have a lot of parallels of this in the software engineering world. We have a lot of parallels for this in cars. There are huge there are swathes of people in the world who are quite happy with Windows Server 2003, which Microsoft has long since abandoned. Microsoft might one day release a fix for the firewall, for example, something critical, something that genuinely affects all of those servers that are still out there. They might actually do that. They could still do that. But they're not going to backport USB 3.2 support into it. And so you have to think, how many people is this going to help in terms of these fixes? Some things genuinely, we should care if IPv4 is broken, properly broken. We should genuinely care about that. We should not care that some people have elected to write a USB 3.2 driver for their IPv4 stack. It's not necessarily going to help as many people as you hope. And ultimately, all of this effort does detract from rolling out IPv6. But that's a couple of questions and a statement, but in particular, I think we really need to be very honest with ourselves about the effort going into this and what it's for.
So I appreciate the distinction that you draw, that there are different kinds of fixes and that there's different scope in the benefit of different fixes. And that may go to arguing that some of the examples that we've given of other ongoing IPv4 maintenance may not be viewed as exactly analogous to our proposals. And without having analyzed all of the details under that rubric, I can say that seems to be a possible point of argument. I guess I would say it seems like some of the other fixes have also been fairly specific or fairly limited in what they would do, where some of our fixes have the potential to alleviate scarcity problems for a fairly significant number of organizations, admittedly with potentially some appreciable delay. But so I guess I would say I would take the point conceptually that there are many different kinds of fixes and that they may be analyzed differently, and say I also think that our proposed fixes have a lot of potential down the road to benefit a lot of people and a lot of organizations.
Hey, Jen Linkova, 2 comments. First, yeah, I'd like to second to what's been said. In my understanding, when we're talking about a product being in maintenance mode, it means we are fixing bugs, serious bugs like security issues, but we're not developing anything new in that product and focusing on whatever product is active now. So I think it's what we should be doing with IPv4. So I have no objections to v4 being in maintenance mode, but it doesn't mean we're going to develop new stuff there. And secondly, I'm a bit confused about a few slides in your presentation. So you propose, if some work did not get enough consensus and not enough interest, do you think that getting higher level statement about doing more work in IPv4 would help? I was under impression that you bring in some work to ATF. If there are people who want to do this and there is consensus, you can do it even if you don't have a large statement about that stuff. So I'm not sure what you're trying to achieve by having consensus on IPv4 maintenance.
Thanks. Yeah, I think we were trying in large part to respond to the tenor and the focus of concerns that people had and that people expressed on the mailing list, and also at the prior meeting, where in our perception and our understanding, a lot of people didn't say so much, oh, this won't work well, or this is infeasible, or this is not beneficial as such, but they said it's IPv4. They said IPv4 is obsolete, or IPv4 is done, or IPv4 is over, or things of that nature. And that was a predominant rationale for people proposing not to work on this or not to do this work. And so I think that's a lot of what we were proposing here to address with consensus.
Okay. Okay, thank you very much. We're going to move now to the next presentation.
Thank you.
Thanks, Seth.
Thanks.
So I'm going to pass you the control, Fred, so that you can move. Oops, I lost the slides. Give me 1 second.
Are you hearing me okay, Juan Carlos?
I can. I hope people online can also hear you well. So I'm going to try once again to pass you the control. And you should be able to move the slides from your side.
Okay, thank you. So this presentation is on a new construct known as IP parcels. Let's see. This is the pointer to the data tracker document. The first version of the document was published in December 2021. It's closely related to the Arrow, Omni, and DTN proposals, where you see the data tracker entries for those. The current draft is the -09, which was published February 10th, 2022. And this presentation is a narrative of the -09. So IP packets, both IP version 4 and version 6, contain data that becomes the retransmission unit in case of loss. Upper layer protocols like QUIC, LTP, and TCP exchange segments, and they include a single segment per IP packet. What IP parcels permits is for a single packet to carry multiple upper layer protocol segments, a packet of packets, if you will. But the segment is still the retransmission and loss unit. The goal is to support larger packets for better performance, to support flexible packaging and repackaging for more efficient handling, and to encourage larger maximum transmission units in the internet. So let me give an analogy. When a consumer orders 50 small items from a major online retailer, for example, you wanted to buy 50 keychains to give out as employee appreciation gifts, The retailer does not ship the order in 50 small separate boxes. Instead, they put as many of the small boxes as possible into one or a few larger boxes or parcels, and then place the parcels on a semi-truck or an airplane. The parcels arrive at a regional distribution center where they may be further redistributed into smaller parcels that get delivered to the consumer, but most often the consumer will only find one or a few parcels at his doorstep and not 50 individual boxes. And this greatly reduces the handling overhead for both the retailer and the consumer. So a parcel is formed when an upper layer protocol identified by the 5 tuples source IP, destination IP, source port, destination port, and protocol produces a buffer with up to 64 upper layer protocol segments. All segments except the final must be equal length. They can be up to 64K octets minus headers. The final segment may be smaller. The upper layer protocol delivers the buffer and the non-final segment size to the IP layer. Then the IP layer forms a parcel by appending a jumbo payload option. And there we have our friend, the jumbo payload option. So IP parcels are based on the jumbograms construct. They include a jumbo payload option, but they have a non-zero value in the payload length field, whereas true jumbos use the value 0 in that payload length field. The payload length gives the length of the first segment only. The jumbo payload length gives the length of the entire parcel. So we have IP parcel support for both V6 and V4. So to do that, we've defined the jumbo payload option for IP version 4. The maximum IP parcel size is the 64 segments times the maximum 64K per segment. Slightly under 4 megabytes is the largest parcel. And here on the right, you see a diagram showing the construct of a parcel where we have an IP header and K segments. J segments, all within the same IP packet. Some related work, a concept known as generic segment and receive offload is implemented in some OSs and NICs. Linux implements it, for example. The upper layer protocol can supply multiple segments in a single system call. There was a study with the QUIC protocol that showed significant performance increases using GSO and GRO. Another study with the Licklider transmission protocol showed moderate increases for small to medium-sized segments with using GSO and GRO, but significant increases for large single segments, even if IP fragmentation and reassembly is needed. Another study known as Big TCP considered end-system internal implications of jumbograms for better performance. So what IP parcels is really proposing is a combination of the results of these studies, which is the GSO, GRO style segmentation plus IP fragmentation with IP jumbograms for network transmissions. So there's several different parcel types. A null parcel is just an IP header with a jumbo payload option and no next header in the next header field. And it's essentially a singleton with a segment length L of 0. Then a singleton parcel is an IP header with jumbo payload option and a single upper layer protocol segment of length L. Then a multi-segment parcel is an IP header with jumbo payload option, J-1 upper layer protocol segments of length L, and the final upper layer protocol segment of length K, which must be less than or equal to L. Transmission of IP parcels. IP parcels traverse parcel-capable links that have sufficient MTU, the same as an IP packet would do. But parcel-capable links are not yet widely deployed in heterogeneous internetworks. But an adaptation layer can forward parcels in an overlay. The Omni adaptation layer in particular uses encapsulation and fragmentation. The Omni adaptation layer breaks parcels into smaller subparcels if necessary, since the largest that can undergo IP fragmentation is 64K octets. So there's a first pass in the adaptation layer in which parcel fragmentation occurs. These are loosely reassembled with opportunistic merging, and a second pass in which IP fragmentation is applied to individual subparcels. And here we need strict reassembly with fragment retransmission if necessary. So the goal is to forward the fewest and largest IP parcels possible over the network to the final destination. Minimize segment reordering due to reparceling if possible, but this is not a critical consideration. Leverage IP fragmentation and reassembly for greater performance. And the lost unit becomes a single segment instead of the entire IP parcel. So how do we find out if a path can handle IP parcels? We want to qualify the head of the source to destination forward path as parcel capable so we can support incremental deployment of parcel capable links. So a parcel probe from the source can test consecutive hops up to the destination itself or to a router that has a non-parcel capable next hop. And for this, we use the hop by hop option. It's processed at each hop. The parcel reply comes from either the final destination or the router that informs the source the head of the forward parcel path parcel is capable. And this parcel reply is placed in a destination option so that it's only processed at the source. So after the parcel path qualification, parcels from the source can traverse parcel capable paths the same as ordinary IP packets up to either the end destination or the router that terminates the parcel capable path. And then the routers that terminate parcel capable paths open the parcels and forward individual IP packets to the destination. So in other words, we want to drive parcels forward as far as forward as possible into the forward path from the source to the destination. Now, in terms of integrity, link layer checks like CRC32 can miss errors in packets that are larger than about 9K bytes, but IP parcels are often much larger. But fortunately, IP parcels include a separate integrity check for each upper layer protocol segment. So if there's many of them, there's many integrity checks in the parcel. So the parcels improve integrity in comparison to the same size jumbograms would provide, because the jumbos only include a single upper layer protocol segment and integrity check. So the next steps are that we want to, we see that IP parcels increase efficiency and performance for end systems. IP parcels provide a path forward for larger MTUs in the internet. IP parcel spec is in advanced stages of development. Here it is, the point of the data tracker. And I want to ask now if we can adopt IP parcels as a working group item.
Okay, thank you very much for that presentation. So we have no one right now asking questions. To respond to your question about accepting it as a working group item, I guess we would need to see some discussion and some support on the list. So we do have, you have a question? Lars?
Yeah. Hey, Fred, this is Lars Eggert. So I have a question. I might have missed this, but can you say a bit more on the first bullet? How does this increase efficiency and performance, especially for the end systems? Because I don't see it.
So we have two studies that show that by sending multiple segments in a single system call, it reduces the number of interrupts and it reduces the overhead of packaging the parcel. And for transmission across networks that have larger MTUs, larger packets, it incurs fewer interrupts and more efficient.
I don't care. I'm a transport layer guy. I don't care about the network. But so we already do this on the end systems just fine, right? With TCP offloading and other, as you mentioned. So is there additional efficiency to be gained by this over what we're already doing? And where is it coming from?
This was based on the GSO JRO and TSO TRO concepts.
Those efficiencies we have already, right? So these are not new efficiencies with this proposal. These are efficiencies that we already have now.
This proposal was based, yes, on those concepts, but it's allowing the parcels to travel over network paths. Okay, and some network paths. Go ahead.
So basically, there's no additional efficiencies over what we already have with GSO for the end systems.
Yeah. Again, the hosts the end systems get to see the same efficiencies that they get with GSO, GRO, and TSO, TCP segment
you.
offload.
Thank you. Luigi?
Luigi, I had a similar question on the performance side. I mean, in slide 9, if I remember correctly, you say we have a bunch of links that support IP parcel. They may go through links that do not support IP parcels. So basically, you have operation going on inside the network. So at least at the beginning of the deployment, you will have a performance hit because you have to change a little bit the way you aggregate or disaggregate, fragment, or reassembly the packets, right?
If I understood the question correctly, the ability to know when to use parcels is not a performance intensive operation when you send these things called parcel probes, which I'll put the thing back up again. What you would normally do is you'd start sending regular IP packets and then send a parcel path qualification probe. If the probe succeeds, then you can begin sending IP parcels. So there's not any kind of a performance hit for starting to use parcels when it's not possible to use them, for example.
We have time for the continued question.
Next is you.
So if I could understand correctly, what happens if only links in the middle do support IP parcel, but not the end-host, or the links at the end-host? You will not see the IP parcel part because the path doesn't support. Is that correct? It's my understanding.
Right. In that case, you're still sending regular IP packets.
Okay, thank you.
Okay, thank you very much, Fred. So next is Luigi. Do you want me to share slides and pass you the, or you want to? Okay, let's try. Okay.
Okay. Again, I'm Luigi. I'm actually going to present two drafts, an update on 2 drafts about internet addressing. We have out there 2 documents, the problem statement and the gap analysis. A little bit of telenovelas in the sense that what did happen is 112. We had a side meeting at that point, and Dirk reported in this very working group. So based on the side meeting, we formulated 3 questions that you ask to the mailing list. So what exact features do we want from the internet? Where, how is the features innovation happening? And what is in an address anyway? Actually, it was good. It was good because we started with 3 threads, and the discussion spilled all over the way. Actually, IP parcels, if I remember correctly, is a spin-off on a discussion started on the MTU issue about the first question. So for each and every thread, what we did is try to summarize the discussion in an email in order to check if our understanding was okay. And we'll show you that in the next 3 slides. And actually, even after the summarization that we did when we thought the discussion was more or less over, actually, discussion actually went on, which is good. We tried to incorporate everything. This included some private email exchange in order to be sure that we capture correctly what some people said on the email. Okay, so. And actually, we had 3 new co-authors on the document, Laurent Toutan, Abram Chen, and Dino Farinacci. But actually, there is a contribution of a lot of people there. Okay, so first question, what exact features do we want from the internet? The summary of the discussion was a list of features. I just put the keywords, but actually, this resulted in a new section 3 in the problem statement, and each and every point here has been developed in a consistent way with good paragraphs, I would say. So very, very good input that we received. The second one was where and how is the features innovation happening? So the summary of that discussion is that not surprisingly, in a certain way, we have two dimensions. One is the horizontal dimension, so it's edge versus core, okay? The other is a vertical dimension, is about which layer of the protocol stack. So, and obviously, it's not just one of or the other. It happens in a hybrid way, I would say. Then there were points about how much unique and globally routable an address should be. This is somehow linked to the discussions that we see around about internet consolidation or centralization, depends which terminology you like to use. There was a discussion about address privacy. This actually, privacy came up in all of the three questions, in a way or another. Okay, it seems to be very important, and I do agree absolutely. So, and this has evolved mainly in a new section 5 in the gap analysis. The third question: what is an address anyway? So this specific question went beyond any expectations that we had, went beyond the just submission cutoff date. Okay, the discussion went on for a long time. Even recently, there were some follow-up emails on that. Went beyond the entire mailing list, mostly in the architectural discussion. Okay, the points raised is a lot about how ephemeral is an address and what kind of semantic in a certain way it transports, because you can see an address like a opaque instruction that you look up in a table and then you, whatever the table tells you to do with it, okay? And then you have a certain kind of mappings, which could be one-to-one, the classical unicast, or something more evolved. And this has also brought a lot of changes in section 5 on the problem statement document. And again, a little bit here, a little bit there. Everything is on the data tracker. So I will go quickly through the main changes. I apologize for the title that I messed up somehow, didn't notice. There are two sections in the problem statement. 2.7 is about communication protecting privacy. Is work in progress, to be honest. The plan is, because the privacy issues has been raised several times in all the questions, we will try to fetch input from the PRG research group, so the Privacy Enhancement and Assessment Research Group. I think that's the right community to ask for. And then there is this desired network features that is more or less the list that I showed you before. Again, with all the text that comes along in order to describe what are those features. And other important changes are in section 4, we have a new part about hampering privacy. And in the problem statement section itself, we added some input from the discussion that took place actually in the architectural discussion mailing list about the question, what is an address anyway? On the gap analysis document, the main changes is section 5 is a new one. We call it a system view on addresses. It's where we discuss about this two-dimensional space where the innovation takes place, okay? And we try to describe what are the different implications and how it happens, okay? And then there are a bunch of other important changes that we have in several sections about the extension in the length of the addresses, or we added new examples about SHIC, EASIP, or what if we have addresses that are actually longer than 128 bits, okay? And a discussion about semantic extension and some improved conclusion. Now, as for the status of these two documents, now, I gave you just an update on the content. The content of the documents is for the problem statement to provide an example and scenarios where the existing internet addressing is a potential hindrance, okay? And then there is a gap analysis. Why this is happening, what has been done in order to improve in a certain way the addressing, and in a certain way this represents the fact that there are solutions trying to fill in a gap. That's the content. But the real purpose that we said since the beginning was to bring the community to discuss addressing. Okay, and certainly we had a difficult start. Okay, COVID-19 didn't help at all, I would say. But finally, we made it in the sense that there was a lot of discussion, and we tried to gather all the different facets that we saw. We just left out at this stage any discussion or text that was going too much into solution space, because it's not the scope of these two documents, okay? Which brings me to the last slide, to be honest. So I think these two documents document a community effort. All the co-authors that are on board, they do agree that they're bringing value in the sense that document something or concerns that are there, okay? So all the co-authors think that it's worth thinking about working group adoption here in the area, okay? Looking long term, but we don't discuss this now, is worth thinking that what should we do next? And this goes again back to community discussion on what should we do once we agree that these issues are there. Some of us believe they are very important issues. Depending on the issue, something is not that important. It depends on the viewpoint. But yeah, this is long-term about the solution. And that's it from my side. Any question, welcome.
Thanks a lot, Luigi. So are there any questions from the room or online?
So.
Okay. So I guess we need to have some more discussion on the list before answering your questions about the
Even
working
more
group adoption. But yes,
okay.
Please continue liaising this document. Thank you very much. All right. So is Lenny in the room yet?
Remote.
Lenny is still on his way.
Lenny is on his way. So we're going to move to Lynn.
Yes, I'm here.
Okay. Give me 1 second. I'm going to share the slides. And then I'm going to give you control. You should be able to move the slides now, Lynn. Lynn? Lynn Han, can you hear us?
Yes, I can hear you.
Okay, you are up. You can move the slides now.
But I cannot move. How can I move the slides? Oh yeah. Use the. Okay, got it. All right. Hello everyone. This is Lin, and my presentation is about satellite network and problem and solutions from L3 perspective. And this is this work start from probably IETF 111. We published the problem statements, and later on we published some draft about solution. So far we have 3 drafts about solution, but it's still not complete. And last IETF I tried to get opportunity in the area, but I didn't. So this time I'm happy to present our work for this regard. And this is our objective. what we want to do is that we want to explore the open solution for large-scale LEO constellation, which is for internet access and NTN integration. Even we have so many legacy satellite technologies there, but we are dealing with the latest development in this industry, which is like Starlink, over 10,000 satellites, and the service is for the global internet access. And also we want to try to work on the expectation from 3GPP, which is called the NG-RAN, which will integrate the LEO constellation with 5G and the internet. At this moment, what we plan to do is that we want to provide the basic IP connectivity or basic for satellite network. And all drafts so far are only informational experiment. And right now we expect more feedback from different WG. And of course, right now, people may feel confusing to understand whole solution because there's no dedicated working group in IETF. So I can only present different pieces of solution to different working group who is interested. Of course, we will not do anything which relate to 3GPP. For example, for integration part, they have a lot of protocol and defined already in 3GPP, but we not touch it. So what is the problem? Problem is that right now we think the satellite network, LEO satellite constellation is very specific network, which our current IGP, BGP mobility protocol cannot handle it efficiently. And if you want to see more explanation, you can go to this slide deck. We have a kind of presentation before to our collaborator, University of Surrey, to discuss the problems for the satellite and the problems for 3GPP and IETF. And in this slide, I also try to answer questions which raised before IETF meeting and also in the E2 set mail alias. Most of the questions are not very technical details about our proposal. Is about why we need to do this and why the current satellite networking company didn't raise any question to IETF, those kind of things. Also, we give some introduction about the NG-RAN requirements for satellite network. From there, you can see that IP is a kind of infrastructure for their whole architecture. So we have to provide IP connectivity to them. Last, we provide some simulations to mobility, links, and paths. You can see that from there how frequent of this state changes. So it's easier to understand why the current IP technology, which are assumed very static, cannot handle so fast-moving network. Here, I just give more discussing about semantic address because this is probably the interest of this working group. And the semantic address is we designed dedicated for satellite network because satellite network is very special. It's not like the network on ground. Satellite network is very organized. Even they are moving very fast, but they are moving on the same speed if they're on the same altitude. So we propose to use the 3 index to represent each satellite dynamically because those index never change. Even satellite position is changing. So we have a share index which will describe the which share or which layer of satellite. This will be determined only by the altitude and the inclination angle. So if every satellite has the same altitude and inclination angle, those satellites are belong to the same share. The share index will be same. Also, the orbit plane index. Orbit is that from the picture you can see the lines connect different green dots. They are orbits, and the orbit plane is that some satellites will moving on the same orbit. Those index will be same. And the satellite index is that for each satellite on the same orbit, which position or relative index in that orbit. So from this 3 index, we can uniquely identify each satellite in a satellite constellation. And for this same semantic address draft, we for the next update, we add co-author and also add one section, which is a 32-bit semantic address. And why we add this section is because the satellite network is relatively closed. So if we use IPv6, it's pretty much overhead. If we can use a much shorter address, it will be big saving. And the satellite network, the network resource is not like the resource on ground. Their memory, their chip is very expensive. So the saving on the overhead is very valuable to customer. And this one we'll talk about why we, what is a basic routing algorithm we will proposal to satellite network, and why we need to do this, because of satellite network is very special. Current IGP, BGP, we are facing a lot of challenges. And why that? Because we have a very fast link flipping every 5 minutes. And link metrics keep changing because the distance keep changing. And some unstable link also keep flipping. And also the probably the link interruption at the polar area. All above will cause huge IGP flooding message, which will cause the storm of the protocol message. And the service time will be dramatically reduced. So here is a review of how the topology looks like. We have 50% satellites moving to one direction and another 50% satellite moving to different directions. Every satellite moving very fast, more than 7 kilometers per second. And also every device on ground will moving with Earth's rotation, which is also very fast, more than even faster than sound speed. And the link metrics keep changing. And the ground station to satellite link also keep flipping in addition to the link metrics change. So what is the problem using IGP? Of course, IGP can be used here, but the problem is that because the link state changes so frequently, the service time will be dramatically reduced because the number of the unstable link is huge. We have some paper analyzed that said that less than 20% is a kind of usability, which is not tolerable to the service provider. And then when we try to find the solution for the satellite routing, we have to think about the spatial characteristics for satellite network. So first of all, the satellite network is not like the regular network. It is kind of a carrier network. Which means the satellite network, of course, with the inter-satellite link, it will only do the transport work. And satellite network is well organized. So as I said, it's multi-layer of grid network, even interleaved and moving to different direction. Also, there are limited number of inter-satellite link because those links are very expensive. Probably 6 or a little bit more than 6 will be enough for a satellite in 3D space. So we can use a self-explained semantic address to identify each satellite, as I said, for that draft. And importantly is that satellite position is predictable when time is changing, because every satellite orbit element parameters are known. So what we can predict? We can predict the satellite adjacency and the link metrics. All those information, we don't need to measurement and the protocol message to advertise. So here is our hybrid solution. We think we need to use some hybrid technology to get the final solution. And this is the principle. First is that we have to use the computation power in these special issues. And we have to do the computation for dynamic topology, for dynamic link matrix, also predict which ground station to satellite link could be used. Then we have to borrow the IGP. For example, right now we borrow IGP for the network topology and the state detection. And probably we have one draft for this. This draft is just for isolate those links which very unstable. And probably more draft will come for the different other purpose. Also, we will utilize the spatial characteristics. Like I said, the semantic address can be used. Last is that we come out this instructive routing draft for the routing purpose. So the instructive routing is very simple. It's like the semantic routing, but because we use a semantic address, we can greatly compress the header. We don't need to put the segments ID there. We just tell the satellite where to forward the packet, which direction, and until which satellite. This is example. And lastly, I show some packet format because we use a new routing type. So we need to insert a instruction list into the packet, and the packet can be forwarded at each satellite if a satellite network engine can understand what is the instruction. So here is the summary of the interactive routing and what is the advantages. And I probably don't have time to go through all of this. And I think questions?
Okay, thank you very much. We have one person on the queue, Gori.
Hi, Gori Fairhurst. Thanks for the talk. It's really interesting to see the internals of one of these LEO networks. My question is probably, which operators are calling for this work to be done here? I mean, this is an interoperability question. Do we need a standard within satellite systems to do this, or is this just an interior routing protocol, which we just need to view at the edges? So which operators are you talking to, or which manufacturers are asking for this work?
Very good question. I think I have some answer in the problem statement workshop, why IETF need to do this. From our point of view, first of all, the consolidation is, right now the operation model is that such as Starlink, every company provides its own solutions, right? But the problem is that the orbit resource and the spectrum resource is very limited. We think in the future, the satellite network should be shared by different service provider. For example, the LEO orbit, they only can hold about 60,000 satellites. Right now, Starlink consumed 40,000, and the China constellation consumed more than 12,000. So we don't have too many orbit resource right now. So in the future, I believe due to the resource limitation on the orbit and also spectrum, and also some countries' antitrust regulation, the satellite network could be infrastructure. This is also the point from the 3GPP, that the satellite network is just a kind of like a backhaul network. It should be provided the service by different service provider. So from this point of view, we think that the open solution to the satellite network. Also, probably in the future, the different owner of the satellite could have some interoperability issue there.
Can I just follow up with the question? You mentioned Starlink. Did Starlink actually want to do an IP interoperable solution, or does Starlink currently operate a proprietary solution?
I think they're only, right now, the Starlink doesn't need any L2 and L3 solution because they are doing the relay technology. But they are testing the ILCL from this year. However, I don't expect they will do the public solution because there's a currently their business model is private.
Thanks for the presentation. It was very interesting.
Thank you.
Okay, thank you very much. So now we'll move to Lenny's presentation. Lenny?
Okay, I don't see the slide yet. Oh, there it is.
So I'm going to give you control.
All right, thank you. So today I'm going to talk about a draft on considerations for blocking regional internet access. One important note, just a couple of disclaimers. The content and ideas expressed in this are solely the views of the authors, and it does not reflect, as individuals, and it doesn't reflect the views or positions of any of our affiliations. And for those, it kind of goes without saying, but for those who are less familiar with IETF processes, who might be watching as perhaps newcomers, this is an individual contribution and does not reflect or represent IETF consensus.
And this is Eric Vink here. Lenny, if you just allow me to emphasize what you just said for the people listening to this on YouTube later. I am the Internet Area Director, and thank you so much for clearly spelling out that an individual contribution and indeed does not represent the IETF consensus. Sorry for repeating what you just said. Thank you.
Not at all. Thank you, Eric, for clarifying. All right, now let's get to the fun. So just a little bit of background and motivation and the purpose behind this draft. In light of recent geopolitical events, there have been discussions in various circles, technically, non-technically, political, on the concept of blocking internet connectivity for a country or a region. What we wanted to do is describe what that might look like. Kind of some well-known approaches for blocking connectivity that service providers use fairly frequently and commonly. And then describe the implications of each of these approaches. The positive, negative, the advantages, disadvantages. The intended audience for this document is policymakers and kind of the general public at large. Pretty much all the people who aren't in this room, but who are interested in the topic and would like to know, what would this look like? We do not take any position about whether this is a good idea or a bad idea, but what we're trying to provide is some background information on what this might look like, so that those who do have opinions on the matter can have informed opinion. Good policy depends on good, unbiased, sober information. And that's what we're trying to do here. Just kind of describe what is technically possible, how it would work, whether or not it might be effective, and try to anticipate some of the potential intended and unintended consequences of such a policy. What this document is not, we are not, again, advocating for or against any particular policy or position. We're not saying that this is a good idea or a bad idea. We're just reporting the news and let others decide on the basis of some of the information that we're providing. Not providing any political opinion or analysis on the ethics of blocking connectivity to the internet. Also, we'd like, obviously, this document has been inspired by recent events, but it's probably not going to be the last time or the last conflict that might inspire discussions. So we'd like this to be generic enough to be applicable to beyond just a single event and be maybe valuable for the future. And perhaps, you know, it could be useful for before events take place, it could be helpful in maybe guiding actions. It's also not a guide for blocking against security threats. There's some, and I'll talk about some of related work that covers if a network or a region is attacking, blocking that region. That's a completely different issue. This is not protection from a region, but more so about sanction, kind of the internet connectivity equivalent of economic sanctions. Think of it as connectivity sanctions. So that's kind of the use case we've envisioned here. We're also, not producing a how-to guide on weaponizing or, magical industry secrets on killing access. Everything we've limited all of the approaches to well-known ideas and approaches that operators use frequently to legitimately filter and block internet access. So we don't believe that we are giving away or planting seeds or adding any, there's nothing groundbreaking here in terms of what we're doing. These are all well-known, well-understood techniques that have been documented elsewhere, we believe. It's also, we didn't go into the area of malicious attacks, either physically, bombing an infrastructure, or through cyber attacks, or things like DNS cache poisoning. I think those are interesting topics and probably worth another document, but it's kind of outside. It seemed too broad of an area, and it's kind of outside the area of expertise to the authors. So we kept that out of scope for this document. All right, with that out of the way, the actual meat of the document, the blocking techniques. So we kind of start from the physical layer and work our way up. So disconnecting cables, how effective would that be? What that would look like. De-peer, and then moving on to the routing layer and the control plane. Things like de-peering. And next is route filtering, both prefix-based and autonomous system-based. Next, we cover packet layer at the data plane, discussing things like GeoIP, access control lists. And finally, we talk about DNS, things like, undelegating top-level domains or other relevant domains. Also, the idea of blocking resolution requests, either coming from name servers or end hosts in a given region. So as you can see, there's nothing, like I said, groundbreaking, no industry secrets here. These are all pretty common techniques for the most part, maybe not undelegating top-level domains, but these are in use today by operators for legitimate purposes. The next area we talk about is, efficacy. Would this work? What are some of the concerns, consequences, intended and unintended? And the first thing is, from the perspective of a policymaker who might be advocating a position like blocking, this approach may end up being counterproductive. So a policymaker might actually want messages to be able to get into or out of a region, or they might want certain parties, say, oppositional groups, for example, to be able to communicate freely and coordinate activities. It may indeed actually empower a targeted regime that is being targeted for sanction by allowing that regime to consolidate its power by not allowing any other messaging, independent messaging from getting into or out of a region. So this should be kept in mind by a policymaker if considering this approach. The other thing that's obvious is that a network is amoral. It does not discriminate between good bits and bad bits. It just transmits bits, whether those bits comprise desirable or undesirable information. Also, autonomous system numbers and prefixes are not allocated according to geopolitical boundaries. They are loosely allocated based on region, and even that has kind of porous borders. You can, for example, you can fairly easily see all the prefixes or autonomous systems that are allocated to companies that are based in a country. However, over time, those, let's say entities rather than companies, those entities may be, say, acquired by other multinational entities, and those routes and autonomous systems could be advertised from other places in different regions. There's the cloud. In any event, there are porous borders, and it's difficult to neatly say this region or this country only has the routes coming in, from entities that are based in that region. Also, they can be multi-homed in different regions. There is registry information, but that is notoriously inaccurate. And finally, the decentralized nature of the internet makes it pretty much, it's pretty much impossible to completely block a region. This is kind of a feature, not a bug. This is by design. The internet was kind of intended to act like this. That said, you can put a pretty good dent in connectivity and throughput at certain, there are certain choke points where you could pretty significantly restrict access and do some harm if one wanted to actually do that. There has been some prior art in this area. RFC 7754 talks about blocking and filtering, but this document is more focused at kind of higher level, application level, transport host level, rather than network infrastructure. Also, the purpose of this doc is more focused on things like security and objectionability and business arrangement, and less so sanction. So there's a good bit of difference here. That said, there are some overlapping themes on things like efficacy and the importance of specificity when it comes to filtering and blocking. There's a draft in the PEARG working group on censorship. And again, this is more focused on censorship by regimes within their borders, rather than, say, blocking all traffic coming out of that region as, say, sanctioned because of the activities of a regime. So it's more of a directionality difference. But again, there is a little bit of overlap. There is the mention of considerations for service disconnection. In terms of next steps, we'd love to ask this working group, is this document useful? Is it interesting? Is this something that folks in this working group would like to work on? Are there other blocking techniques that we didn't include that should be included? And we are requesting adoption by this working group. So another open question is BCP versus informational. We kind of went back and forth on this. We don't have really strong opinions. We'd be happy to go with consensus if this is adopted. And we'd love review and comments. And with that, I'd be happy to take any questions.
Okay, thank you very much, Lenny. We do have people on the queue. So we start with Ted.
Ted Hardy speaking. Thank you very much for your time in putting this together as a presentation. And I'm particularly appreciative of the fact that you clarified that this was an individual contribution and that you're now asking for comments from the group. I'm about to speak about the Internet Society, and although I am currently on the Board of Trustees of the Internet Society, I want to make it clear that I'm not speaking for them. The reason I want to speak about them is because the questions that you're dealing with in this document have actually been dealt with by the Internet Society for some time. They have been creating impact assessments. There is a generalized framework which they have created to describe the effects of internet blocking and the techniques of internet blocking, and they have over time gone into the specifics of the internet blocking on different territories at different times. So, for example, there was one on the Sudan that was done in 2019. There have been 3 such impact reports on the current geopolitical situation, examining the current efforts to possibly remove Russia from the internet, the request by the Ukraine government to ICANN, and the related impacts of partition of the network by these efforts. So there's a whole bunch of work that is specifically directed toward policymakers that's already been done by ISOC, by Access Now, by others. I would suggest that the authors consider reviewing that work and seeing whether they really see any gaps. Having reviewed this document, I did not. So I don't think that there are techniques that you've described here that are not in them. And I don't think that your address to policymakers is as effective as those other addresses. And that the primary reason for that is those are attempting to describe both the technical activities which are happening and the impact. And it is vitally important that policymakers twin those 2 concerns at once, because they need to understand, in the context of a specific partition of the network, what the impact is, both on the network and on the people who it impacts. That's the policy question from the point of view of those who you believe your intended audience are. And I don't think it's appropriate to try and put these documents out without those impact statements, because the result will be policymakers making decisions without the full picture. And it is desperately important that they understand the full picture in cases like this. So I really discourage IntArea from adopting this. I really believe the right thing to do is to contribute to the policy work that's going on in other forums, whether it be the Internet Society or Access Now or others, and make sure that your expertise is available to them. Trying to do this through here is not going to be as effective because we can't bring in those other pieces to what the policymakers need. Thank you again for your efforts in considering these questions.
Thanks, Ted. Yeah, I think that's great feedback. And there's lots of activities going on. I think I don't have an answer other than to say, what would be, I would turn this back to the consensus of the working group as well and see if others share those opinions and thoughts. So, if we believe that this document doesn't really add anything to what's already out there, then, that's consensus. So.
Thank you. Jen?
Jen Linkova, just a random network engineer. I feel like, let's say you're a doctor and you publish a very well written, very well thought article about 15 best methods to shoot your neighbor in the foot with cost-effective analysis and all this stuff. So it's basically how I feel when I read this.
Again, I don't think we're trying to describe how to shoot your neighbor in the foot as much as if you shot your neighbor in the foot, this is what would happen. So this is what you should think about before shooting your neighbor in the foot. That's kind of, hopefully, that's why it's a considerations document and less a how-to guide.
Okay. Thank you. Alisa?
Thanks. Thanks for the presentation and the disclaimers. So I'm one of the authors of RFC 7754, and I thought I might share a couple of lessons learned from that process because it was not easy, and it shared some of the same flavor, but obviously a very different context. So we started thinking about writing that document also triggered by like a specific event or activity that was occurring, which was proposals of a couple of DNS filtering pieces of legislation in the US Congress. They're called SOPA and PIPA. So that was the genesis for the document. And I think it started out maybe in a not dissimilar form from your document. And then over time, we really, it took a long time to publish. And so completely missed also the, the event that it was trying to impact, because by the time we got to the publication, those bills had already died in Congress. But the time also gave us an opportunity to provide the document with much more structure. And so you pointed out, the focus on particular aspects, like the analytical framework that we used, looking at scope and granularity and efficacy and security of each of the different blocking techniques. But we started much more towards what you have, which is, not so much of a framework. But I think that the key difference between that document and this one is that ultimately it does have a bit of a normative valence, because it's trying to show which of the techniques are consistent with the internet's architecture and which ones are not. And I think in the case of this like mass scale blocking, that isn't really possible, right? Because if you're disconnecting from the network, then you are inherently not consistent with its architecture. And so I think other than in these sort of one-off kind of limited deep hearing cases, you can't really avoid that with the disconnection or the block, the outright blocking case. And that makes the trade-off between any value that you get from publishing this document and the potential downsides of, implicitly appearing to endorse any of the techniques, it's just a much different trade-off, I think, which speaks in favor of not advancing this kind of document. And I don't think you can really avoid a political reading or the political implications of it, even if you don't say anything about that in the document itself. I think it will be read as an endorsement. So I am, not supporting of the document moving forward. Thanks.
Yeah, again, if someone reads this as an endorsement of blocking internet access, I'm for a region, I'm not sure. I'm not sure they're reading it clearly, or perhaps we're not being clear enough. So that's certainly not the intention implicitly or explicitly.
Thank you.
Rüdiger Volk, retired backbone engineer. A question that Lenny might answer at the end is, have you drawn on any expertise in diplomacy to figure out how the perception and the related side effects of having such a paper published have to be expected and can be controlled? Looking at just the first few lines of the paper, I find, I'm quite sure it is a really bad idea to brand this thing as a best current practice, and then talk about the topic in the first sentence to raise the question whether this is and how it can be a constructive tactic. Just look at the text. It's the last two words of the first sentence of the abstract. I feel that whatever technical, relevant, and correct input information follows in the paper, if you begin this way, you are inviting people to interpret this and republish as either a threat of doing something or the invitation to do something like this. And Well, okay, if you really feed the public discussion like this, that's something that can hardly be repaired. So I would urge the authors, if they haven't done so far, to really invoke qualified diplomatic expertise to figure out what the effects of what they are doing can be. Having a German historical background, I can tell, well, okay, just the fact that people did know that there was the Heisenberg group doing nuclear research in Germany during the Third Reich. Well, okay, that resulted in having the Manhattan Project. And, well, okay, the reverberations of that project are still hitting us today. Thanks.
In terms of the first question on did we consult diplomatic resources, we did not. The authors wrote this in their individual capacities as engineers with the intent of providing information, the goal of which would be so that the layman, the layperson, could find this as helpful information in understanding these issues. We intended it to be sober, without opinion, one way or the other, and we tried to take great pains to make it clear that we were not endorsing, supporting, or advocating any position one way or the other, but just providing kind of a, staying in our swimming lanes as engineers of this is what some of the things that someone might suggest doing, this is how it would work, and this is what it might do or might not do. Again, as informational purposes for policymakers and the public at large who want to understand what these policies might actually accomplish. We would welcome if we didn't do a good enough job, and if there are better ideas for making that more clear in terms of not advocating a position. Like I said, that was our goal. But if others have better text suggestions, we'd be more than welcome to it. I see your point on BCP. Like I said, it's an open question, BCP versus informational. We don't have a strong opinion one way or the other, and we'd be happy to accept consensus. And I think there was a final point. Does just merely mentioning this plant the seeds and codify the idea and make it a legitimate thing just by mentioning it? The only thing I would say is that kind of ignoring a subject and not having not saying anything about speaking about an elephant in the room doesn't make that elephant go away. Not sure that's the right metaphor, but I'm not sure these ideas would just disappear or seem to be endorsed if it was merely mentioned. So I think it's up to the, we'd be happy to hear the consensus of the working group, whether or not the question is, is this an appropriate thing, and is there interest in discussing these issues?
Tom?
Hi, Lenny. Tom Hill, speaking entirely as an individual internet contributor. I suspect it was a necessary evil that there was going to be a technical response to what is effectively a political question, and I think you've written very well and shown that clearly this is something that you don't support, which is good. I wanted to draw your attention on the basis that there is a difference between what you say and how you say it and how you publish it. Have you seen any of the Internet Sanctions Project and the letter?
I'm not familiar with. No, I'm not familiar with that work.
I would advise you to have a look at that. I think in terms of the way in which we go about this, there will ultimately need to be a technical answer. I fear potentially the raw information, just throwing it out there, may not have been the most considered approach. So in terms of the questions posed in BCP versus informational, I think is moot. I don't believe that there should be any further work done to this draft, and I certainly wouldn't support adoption by any working group. Thank you very much.
Thank you.
Thanks. Benjamin?
Hi, Ben Schwartz. I think that I appreciate that you're looking for an opportunity to do something constructive here, and I think that it needs a little more thought to figure out what that is. One possibility that I could imagine is starting from the other end of the problem, and also taking a longer time horizon. I think that just since the time that you wrote this draft, I think the events that inspired it have already evolved pretty radically. I suspect that the draft would look very different if it was written today instead of 2 weeks ago. And so I think that there's a need to take a longer time horizon. And I also, echoing other comments, think that the sort of attempt at a neutral technical presentation here doesn't really get to the heart of the matter, because this is not a technical problem. So I think that one thing that might be more productive is to start by going to an organization that doesn't have to be neutral at all on this topic, and can actually make some sort of normative statement. That might be the IAB, or it might be another body. But to start there and then potentially revisit this document in light of what could serve their goals.
Yeah, and again, we're not trying to advocate for or against anything. What we're trying to do is provide technical expertise so that those who do form those opinions and advocate for those policies can have an informed, be better informed as they advocate for those policies.
Thanks. Thank you, Mallory.
Hi, everyone. Mallory Nodal from the Center for Democracy and Technology. Yeah, I first want to just say I think the discussion has been interesting, and I welcome that. Noting as well that you are all presenting tomorrow at the Human Rights Protocol Considerations Research Group meeting, which is in the first session tomorrow, where I think it might be interesting to queue up more of these sort of thorny discussions of the politics. So I actually welcome that discussion, even if, like others, I disagree that the draft should move forward in its current form. But I've also previously reached out to you as authors, because I think that the effort to try to describe problems for the internet, which is done in the censorship draft that you've obviously read and you noted in your slides, is an important one. I mean, there's a lot of balance that needs to be taken into consideration that Alyssa and others have pointed out. And if that draft, which the censorship draft is from November 2014, so we're talking a very long time to be able to get around to describing these things in just the right way, with the intention of helping network operators fix it, route around it, like harden the network against censorship, obviously not the other way around. And I think that if there are ways in which that draft could do that better based on your read of things from the IP blocking space, geo blocking space, I think we'd welcome text, although we're about to put that draft into another last call. I think that may be a place where you could do a very thorough review and make sure that we are actually considering the ways in which geo-blocking is done, especially IP blocking, because I don't know that that's as present and prevalent as it should be. Again, for the purposes of identifying weaknesses in the network that could be further hardened against these kinds of censorship, whether it is lawful, proportionate, or other kinds of questions. And I would just say that, you know, and not to lay it on, because I think others have done a good job and you've responded, but, you know, the IETF's in the business of keeping things connected. I think that even if there were sanctions, even if there were calls for the internet connectivity to be included in those sanctions, which currently in this very specific situation, it has not been and has never been in the past. If we're talking about Syria, Iran, Iraq, Afghanistan, like no sanctions have included internet connectivity so far. Even if there were, we would want the IETF to probably resist that, right, in whatever ways it can, either by explaining that it's, you know, not proportionate, that that's not what we're in the business of doing. If we even take a political stance, I think that's really important. So anyway, those are my thoughts. Thanks so much. Look forward to speaking with you about it tomorrow as well.
Great, thanks, Mallory. And just for the purpose of transparency, we presented this at IPEG on Sunday, and we, as Mallory mentioned, we're going to share this with HRPC tomorrow, not for the purpose of working group shopping. It's really Interia was the only work group we had intended to request adoption, but more to share these ideas and get more review and feedback from a broader scope of the community.
Okay, thank you very much. I think you got quite a bit of interesting feedback, and I would actually encourage you to look at the references. If ever the audio was not very clear, we got a whole bunch of references, bodies, and documents that probably you should consider. So we'll make sure that those are captured in the minutes if ever you miss them. But I think the feedback was quite clear that at this moment the group doesn't believe this is a document that should move forward. However, it's an interesting topic that can be discussed either here or in some other forum.
Thank you.
Thanks, and thank you very much. All right. So we're a bit short in time, and we're planning to do some 3 minutes at the end to run a few questions about the interest on the drafts that have called for adoption. So we're going to call Tony now to present, and if you can do it quickly, it'll be appreciated.
All right, thank you. So this talk is on higher levels of address aggregation. This is something of a footnote on the discussions that we had in CIDR 30 years ago. So this is very much a footnote. So back when we started talking about CIDR, we talked about simple aggregation and advertising things. We talked a little bit about aggregating entire continents and regions, but I don't think anything happened about that at all. And I just wanted to revisit that with a couple of new ideas. One thing that's happened differently is that we've been leaking a lot of more specifics for traffic engineering. And that's had a lot of bad effects. It's caused a lot of noise in the BGP routing table. if we could do aggregation of these, it would be very helpful in reducing the routing table. We also have a new idea that basically, actually it was old, but it did not get written down, for how to think about aggregation. I wanted to get this written down before I forget about it or retire. And we did talk about proxy aggregation long ago. That got shot down. But what happens if we did unilateral remote aggregation? So traditional aggregation, we have an ISP. He's got a prefix P. He advertises that out of his borders. All is happy in the world. New concept. We want to clarify and say that the abstraction happens at a boundary. And we want to call that specific boundary of the ISP the abstraction naming boundary. That's the border thing that we are abstracting. And the next new idea is the concept called abstraction action boundary. And this is 100% due to Noel Chiappa. I'd like to thank him for suggesting this. Basically, the idea is that we don't have to aggregate necessarily at the ISP boundary. We can aggregate one or two or many steps past that point. So in this case, the abstraction naming boundary is still the ISP with his prefix P. He's generating lots of more specifics. They make it some way into the network, and then the oval is the abstraction action boundary where we now aggregate and advertise P. What happens if a remote AS decides to do remote aggregation? They decide they're on that abstraction action boundary, and they stop advertising and propagating more specifics and just advertise the aggregate. As far as I can tell, this is actually something that works. The more specifics are going to cause traffic to route around ISP B, but B is still providing reachability, so he's not strictly in violation of transit requirements. If B does his aggregation on ingress, he can actually reduce the load on his routers because he's not carrying more specifics internally. If the aggregation happens on egress, ISP B can still do the traffic engineering, but now he's advertising less to his neighbors. As far as I know, this could be acceptable in some cases. And could we be doing this to improve organizational, continental, or regional aggregation? Right now, regional aggregation is possible. I take a look. I want to talk about the IPv6 address space because that's the most obvious. We've assigned some nice large prefixes to our RIRs. Things like /12s are now common. And these are fine candidates for remote aggregation. If you could do remote aggregation here, you would filter out the traffic engineering more specifics. You would hide all of the RIR specific organizations and could just reduce the amount of noise in the routing table. How do we figure out where we should do this? Where is the abstraction action boundary? If we do it too close to the region, we're going to break traffic engineering. We know that. Traffic's not going to go the way we intend. If we are too far away from the region, then we know that that's wasteful. We're carrying around longer prefixes more than we need to. So some field input here would be very interesting if folks could sit and think about how they would like to do this. Just as a recollection, this is the map of where our RIRs currently are. As you can see, they are mostly aligned with continental boundaries, but not exactly. If you wanted to aggregate a right prefix, for example, you might take and pick this line that I've shown here in color, and that might be your abstraction action boundary. Because it's across a bunch of transoceanic links and transcontinental links, where there are presumably fewer links, you would capture the necessary parts for traffic engineering and wouldn't lose any significant route optimality. Okay. Similarly, you could do this on the continental basis. And I'm going to pick on Jeff Houston in Australia and say, okay, if we want to do some allocations to Australia, and then we could do aggregation around Australia. Right
Sorry,
now,
Tony, could you speed up so that we have a little time for the last presenter? Thanks.
I'm almost done. There are some RPKI issues that we have to talk about. And very much would love to hear from people trying to do this. Okay, thank you.
Okay, thank you very much. We have Dino. We'll take one question.
Hi, this is Dino. Can you hear me okay?
Yes.
Yep.
Yeah. So, Tony, when you were talking about where the abstraction action boundaries should be, you know, we've thought about this for a long time, if it should be done on ingress versus egress. And the thing about proxy aggregation, as you well know, is that when you proxy aggregate, I call it kind of, sometimes you lie, because if you advertise P to somebody, you're making the assumption that you can reach everything that's inside of P, everything that's more specific from it. And if you're carrying the more specifics inside, then you could actually drop at that boundary versus aggregating on ingress, which means you believe you can forward all the way to the edges of the SP, and then you give it to your neighbors, your adjacent neighbors, and they may not have the more specifics and have to drop it. So it sounds to me logically and more efficiently that you'd want to aggregate on egress to maybe tail sites versus transits. I'm not sure about that, but that's just kind of what my hunch feels right now. Comment?
I would love to discuss this with you. Given the press for time, let's take it offline.
Okay, sure.
Thank you very much to both. Zongpeng.
Can you hear me? Okay. Hello everyone. I'm Zongpeng from China Mobile, and this is a new draft, and it's about service routing in the MEC. Next page, please.
Yeah, you should be able to move this page, the page.
Okay. Oh, thank you. This is about the background. The mobile operators are deploying this MEC to provide service with lower latency to their users. And in this MEC scenario, a UPF will work as a gateway of the UE, and under the tunnel from the UE, and some local service can provide in this MEC. Traditionally, a DNS procedure will be needed when the UE access this local service in the MEC. We introduced a mechanism that can access the service directly without this DNS procedure. And this page about the mechanism. The UE have a session with the UPF in the MEC, and the UE knows that it can access the service more quickly within the MEC. And we think that the UE and the MEC is in a limited domain, so the UE can do two attempts. The first attempt is the normal DNS request. For example, request a service from this www.localweather.com. And the second attempt is it can make a destination IP address itself. For example, by hashing the URL. So it can use this IP destination IP to access the service directly, bypass the DNS. If this attempt to success, the UE can access the service directly. And we think the way of making the destination address is there are several options, and so we propose the draft to see whether more people are interested. Thank you. That's all. Any comments?
Oh, sorry. The queue was close to the last one, but you do have 3 people on the queue? 2 people on the queue? 3 people. Benjamin?
Hi, Ben Schwartz. It seems to me that anything that involves hashing the URL creates a privacy violation. It reveals the path information from something like an HTTPS URL, which is confidential. That's one concern. Also, even if this were somehow restricted to the domain name, with the advent of DNS privacy, it is far from a given that the domain name is considered public information. That may also be considered private information that shouldn't be revealed in the IP address, which is necessarily public.
Hi,
Okay, thank
Tom
you.
Hill. Tom Hill. I'm just being quick, BT. How do you, sorry, excuse me, I'll speak up. How, when you are hashing the URL, do you make sure that it does not resolve to an IP address that squats on someone else's IP address, which you then have to route internally?
We think that it's in a limited domain, and we do not have too much. These local services need to be hashed. Perhaps several important services need this low latency service. So we think there are no conflicts.
Okay.
Thank you.
Okay, thank you very much. We are out of time and we won't have time to run the questions, but we did have 3 authors asking for adoption and feedback from the group. So we'll take that to the list regarding sets, IP policing, IPv4 policing, IP parcels from Fred, and the internet addressing gaps from Luigi. So we'll take those on the list. Thank you very much, everyone. Bye.
Bye.
I wanted to have it a little more interactive.
Where the Emperor of Light
cannot stay completely quiet in a responsible way, but speaking in a responsible way, it's far trickier than what I did. Yeah, kind of. I have really trouble in discussing what the Ukrainians are doing wrong under this stress. Yeah. Oh!